Hello everyone. Today we're going to be talking about option contracts. We talked about forward contracts in the previous video, and we also mentioned how you could lose a lot of money potentially from those contracts. So imagine you're a person that likes the aspect of a forward contract that stipulates a price now in the present for an asset in the future, which means you don't have as much uncertainty of the future, but you don't like the fact that you could lose a lot of money from it, right? So that's where option contracts come into play. Now, I need to mention that there are several types of option contracts. Okay, let me start here. Options. They're European, American, the two most common ones, and there are other types. We're only going to be focusing on European options, but I'm also going to be mentioning American options, just how they work, just so you know. Okay, what is an option? An option is, again, like in forward, a two-sided deal, contract. Contract where we have, again, a holder and a writer. We're going to start by explaining the call options, okay? Call options. And then here we'll do the put options. And these two categories are within the European option, by the way. They're not a different type of option. They're just two separate types. In the call, the holder has, here's the key thing. It has the right, but not the obligation to buy a certain asset in the future or a stipulated price, etc. So it has the right, but not obligation. To buy. And the writer is on the other side. So if this person wants to buy, you have to sell. If they don't want to buy, you're good. You don't have to do anything. So we're going to start by defining a few terms. Again, we're going to have, this is going to be done, the contract say at a time t in the present, small t, and the time at which they need to deliver, it's going to be time big T, the same as before, but this is now, instead of being called maturity date, it's called expiry date. And here, by the way, the European option, well, I'll explain that later, never mind. Okay, what else? Now, instead of being called, well, the price at which they agree on to buy or sell the asset in the future, instead of being called the forward price, it's going to be called the strike price, okay? And it's going to be denoted by a K. So, strike price, it's going to be K, and then the expiry date. Just to get used to the words. Okay. So let's take a look at a bit at how this contract would work at the expiry date. So we've agreed upon the strike price, the expiry date, everything's good. And by the way, this is something that we'll mention now. I mentioned before that the forward contracts don't cost anything. Both parties can come into a contract in general, by the way, without paying anything. It's free to get into the contract. And here, the holder, which is the person that has the right, but not the obligation, has to pay some amount. Why? Well, because it has the right, but not the obligation, it can basically decide that at time t, if the outcome is favorable, to exercise his rights and buy. But if he doesn't like to buy, he can say, no, I'm good, I won't buy it. So he's guaranteed to make some money from at time big T. So in exchange, it has to pay the writer, and the writer is, by the way, guaranteed to lose some money at time big T. So he has to pay some amount to the writer at the beginning, at time small t, to make up for that amount of money that he's guaranteed to lose, or maybe not make any money, or maybe not lose any money, sorry. And this one, the amount of money that he's guaranteed to win, or at least not lose any money. Okay, so let's look a bit at how this would work. Again, we're going to denote, by the way, underlying asset by S. S is the underlying asset, ST is the price at time small t, and ST is the price at time at the expiry date. So let's look at how much money the holder is going to make from the deal at expiry. Payoff. Okay, well, and here's K. Here's the expiry. Here's the price at which they've agreed to the holder to buy and the writer to sell. Well, if the stock price, and we're also going to assume that it's a stock. These are more common, the options for stocks, whereas forwards are more common sometimes for, say, copper, corn, stuff like that. Yeah, okay. So, I got lost my train of thought. Okay, so suppose the price of this underlying asset at expiry is higher than K. This means that the holder has the right to buy at K an asset that's worth now ST, which is higher than K. So it's obviously going to exercise that right. It's going to make money. So if ST is greater than or equal to K, the holder is going to exercise his rights. It's going to, and he's going to make ST minus K. He's going to be buying an asset that's worth ST for K. So he's going to make money. If ST is smaller than K, which means that he would have to buy a stock that's worth ST, as big T, for K, which means he's buying something more expensive that he could buy in the market. He's not going to exercise that right. He's going to say, it's not worth it, I'm going to lose money, so I won't do it. Again, it's a right, but not an obligation. So, he's going to be making 0 from this deal if this happens. Again, you can see that he can only, in this case, he's going to be making money, positive, and in this case, he's not going to be losing any money. So that's why I said before that this one has to pay this one some amount of money, because he's guaranteed to at least not lose money, and he can make money. So so the graph of this is going to look something like this. Here he's going to make 0, 0, 0, right? When ST is smaller than K, he's not going to exercise that right. But then from here onwards, he's going to make this amount of money. And the opposite, the writer, the payoff, is on the other side. So he has to make the opposite amount of money. So in these conditions, he's not going to make any money because this person's not going to exercise his rights. Like the contract is well, I'll explain that in a minute. But if ST is greater than or equal to K, the holder's going to exercise his rights, and he's going to have to sell an asset at K that he could sell at ST in the market had he not gone into this contract. Now, when ST is here, when ST is greater than K, it's said to be in the money. The option is said to be in the money. If it's less than K, it's said to be out of the money. And here, I don't have any space. Right at K, it's said to be at the money. So, again, holder's going to make money if it's in the money, and otherwise he's going to make 0. So that's why he has to pay an amount. Okay, we're also going to denote CT as the money that the holder has to pay the writer for this contract. Okay, C because call, CT. Now, the put works in a very similar way. Instead of the holder having the right but not the obligation to buy, the holder has the right but not the obligation to sell. Write this down. Holder rights but not obligation to sell. And the writer is on the other side, right? It has to do whatever the holder decides to do. Again, we're going to use the same notation for strike price, expiry date, underlying asset, and instead of CT, the price that the holder has to pay the writer is going to be called PT. We're going to denote PT, right? P of puts. Well, that's PT. There we go. Okay, so now we're going to, again, focus on the two possible scenarios. If ST is greater than or equal to, let's do greater than, sorry, K. This means that the person here who has the right but not the obligation to sell, at this price, actually let's do the other side first. Sorry about that. He's going to be able to sell at K an asset that's worth S big T, which is smaller than that. So he's going to be making money. So here he's going to exercise his rights, but not the obligation to sell. So he's going to be making K minus ST. If, on the other hand, ST is greater than K, he's going to be, if he were to exercise the rights, he would have to sell an asset, the underlying asset, for K, but it's worth ST in the market. So he's not going to do that. He's going to not exercise this option and he's going to sell it in the market directly. So here he's not going to make any money from this trade, from this contract, sorry. And it's going to look something like this. Oh, also, by the way, I forgot, I'll mention that here. The holder is still set to hold the long position, so it's another synonym for saying holder, and the writer the short, and here the same. Long, short. So, we have the K. And it's going to be the opposite. If ST, let's plot everything, pay off. And I forgot to pay off. This is the holder. This is the writer. In this case, if ST is smaller than K, he's going to be making the money. And K minus ST, so it's going to have a negative gradient with intercept K. This is the holder. And the writer is going to be on the other side of the deal. He's going to be losing all this money. And if it's greater than K, they're both going to make 0. They're on the other side of the deal. Now, this function here is just a max of ST minus K for the holder. Sorry, 0. And this one is max K minus ST 0, which we're going to denote, by the way, ST minus K with a plus sign. So whenever you see this, it's just going to mean the max of this thing here and 0. K minus ST plus. Okay, so this is going to be the payoff for the call option and the put option for the holder, the writer, the writer. Writers here. Now, I'm going to be rubbing some stuff out. Here we go. Okay, now here's the key. In European options, the holder has the right but not the obligation to buy only at the expiry date. Only. He cannot exercise that right before. Whereas American options, the holder has the right but not the obligation to buy, or if it's a put, to sell at any time between the current time and the expiry date. So if halfway through the price is, so imagine the seller, right, but not the obligation to sell. If halfway through the price goes through the roof and he could sell something really expensive, he could make a lot of money, he'll exercise that right. But in the European option, he has to wait until the end. It's only the American that he can exercise it from the beginning to the very end. And then other types of options, you can do it at certain times with certain conditions. It can get very complicated. So, options, let's get rid of this. I think I'll write everything down again. Yeah, I think I'll just write everything down again over here. Okay, I'm gonna leave this stuff over here. And this was the holders, the payoff for the holders. Holder in a call and in a put. 1 second, sorry. Sorry, my dog was crying. I don't know if you heard that. Okay, I'm just gonna leave this. This is enough. Okay, so now the complicated thing about options is that in the same way that I said that forwards, the value did not depend on whether the underlying asset was overvalued, undervalued, what its price could be in the future. It just depended on the current price and the interest rate. In the case of options, if you wanna price it and have with the principle of no arbitrage, so if you want a fair price, you need to take into account the possibilities in the future. You need to take into account how much the stock might be worth, the probabilities, that kind of stuff. So in this video, we're gonna prove instead a theorem that's called the put-call parity. This only relates the price of a put option and a call option, which was the PT and CT that I said before, by the way. Okay? In order to itself value PT alone or CT alone, we need a much more advanced analysis, which we will be doing on future videos. Again, only in very simplified cases because it gets very complicated very fast. Okay, put-call parity. What does a put-call parity say? CT minus PT equals ST minus K E minus R T minus T. I'm also going to be introducing some terminology. The price that the holder pays the writer for a call or a put option is called the premium, okay? The premium of the option. So this is saying that in order for the no arbitrage principle to be satisfied, the premium for a call option minus the premium for a put option has to satisfy this equation. Strike price, the spot price. Spot price means the price at the present of the underlying asset, and then discounted by the time value of money, which is this E minus RT minus T. How do we prove this? Well, we're going to prove it in the same way that we proved the value or the price for a forward contract. We're going to build a portfolio at time T, at the present time, and we're going to see what it leads to. So we're going to start by being the holder of a call option with maturity date T, strike price K. Now we're the holders, which means we're going to be making money. So we're going to have to be paying someone minus CT. This amount of money in cash that's costing us to enter this contract. And then we're also going to be on the other side of a put option. We're going to be the writers of a put option TK. Now we're on the other side. We're getting paid because the other side's going to be making money 100%. So we're getting paid PT in cash, the premiums. And then we're going to do one last thing. We're going to short the underlying asset. We're going to have minus, we're going to sell a stock, say it's a stock. Also, we're assuming that stocks don't pay dividends, by the way. And we're going to obtain from this selling, we're short selling, this thing that I explained in the previous video. You borrow a stock from someone, and then you sell it, and then you have to give it back at a future time. And we're obtaining SBT from this stock. That's what someone's paying us, right? We're borrowing the stock, selling it, obtain money. This is the money that we have. So the total worth of this is 0 in cash, right? This is cash. It's worth 0 because we've offset everything with every other thing. This is worth this is worth this, and this is worth this. Now, let's see what happens at time big T, at expiry date. Holder call. what's the payoff? ST minus K. With the minus sign, that again, I remind you, saying this just means the max of X and 0. That's the definition of it. This one. Well, we said that the holder of a put option makes this amount of money, but we're not the holder, we're the writer, we're on the other side. So we make minus this amount. So we're going to make minus K minus ST plus. And now, the stock, we're still going to have minus 1 stock. And then all this cash, these three things, we're going to invest into the riskless investment, which is a bond or anything, and we're going to end up with, if we add them all together, ST plus PT minus CT ERT minus T. This is the interest rate for the riskless investment. Okay, so what's the price of all of this? The price or the value? We're going to have to subtract these two together. And to do this, we're going to consider cases. Case 1. ST equals K. This thing inside is going to be 0. So it's going to be 0. This whole thing is going to be the max of 0 and 0, so 0. And this thing inside is also going to be 0 with a minus sign, so it's again going to be 0. So these two add up to 0 in the first case. Case 2. ST is greater than K. Then this is going to be greater than 0, and this is going to be smaller than 0. So the max of this and 0 is going to be the thing inside, ST minus K. And again, we said this was going to be negative, so the max of this and 0 is going to be 0, so it's 0. This is what it's worth. And then in the final case, case 3, ST is more than K. We could have grouped this into one of these by just saying this, but I didn't want to confuse anyone by the lack of symmetry, so I'll just consider it separately. K minus ST. This is going to be greater than less than 0, so it's going to be 0 at the very top, and this one's going to be K minus ST is going to be positive, so it's going to be minus K minus ST. Okay? Which if we rearrange is going to be ST minus K. Now we can cleverly rewrite the 0 at the very top as ST minus K as well. Why? Because ST is equal to K in this case. So ST minus K is just equal to 0. So in all three cases, this is just a rearranging version of this. So I'm going to write this off. ST minus K. In all three cases, the sum of these two things, the payoff of these two things is going to be just ST minus K. Now we have this term here, ST plus PT minus CT ERT minus T. And then we have a stock. Right now, what's it worth? Well, it's worth ST. Right time big T. This is what it's worth. Here it's worth S small t. We have to sell it. We have a negative amount of this. We have to buy one to give it back to the person we borrowed it, remember? So we have minus S big T. So we can cancel this and this one out. So I'm just going to write the minus K over here and get rid of the minus ST, ST, and the minus K. So this is the final amount of money that we have in cash, or the value of it. I'm going to erase this to avoid getting confused. Okay, so using the same reasoning as the previous video with the forwards and the no arbitrage, we start with something that's less than or equal to 0, which is 0. 0 is less than or equal to 0. By no arbitrage, also we're guaranteed to get this amount at the end, right? With our portfolio, everything balances out, so this is what we have guaranteed at the end. So this has to be less than or equal to 0. Because if it were positive, greater than 0, this would be an arbitrage opportunity, and we said there's no arbitrage. If this were the case, that this was greater than 0, someone would exploit this immediately, and the prices would balance out. Okay, so we arrive at the conclusion that this whole thing here, ST plus PT minus CT ERT minus T minus K is less than or equal to 0. And in a similar way to the forward contract video, if we do the negative of this portfolio, so we become the writer of a call, the holder of a put, positive amount of CT, negative amount of PT, positive amount of stock, and negative amount of ST cash. And we go all the way here, we're on the other side of every single contract. So we'll end up with negative this amount. So again, we deduce that the minus of this is more than or equal to 0, which means that this thing here all has to be equal to 0. Now rearranging, this becomes CT minus PT. We're going to put these on that side. ERT minus T equals ST minus K. Right, I should maybe do this a bit further down. And now, sorry, I'm missing, what have I done? ST, ERT minus T minus K. Now, we can divide everything by this thing here. ST minus K, E minus R, T minus T. Ta-da! And so that's the put call parity theorem proven. So yeah, that's this video. Hope you enjoyed it.